I recently heard that Apache Kafka does not store data on disks. Yeah, I'm not kidding. My mate told me that Kafka manages most of the operations in memory and doesn't rely heavily on disks. That seemed odd to me, and today I will try to investigate Kafka's persistence process in detail. I'm Alex Sergenko, and this is Alex Try to Understand series. Let's go. Don't fear the file system, that's how the persistence section starts in the official Kafka documentation. I attempted to emanate a section synopsis, and here's what I got. The most efficient way to use spinning disks is linear writing because it's pretty snappy and has a high throughput due to predictable behavior and strong optimization from operational systems. It sounds weird, but sequential disk access can be faster than random memory access. Solid-state drives in turn have much higher random read and write rates compared to HDDs and can be utilized even more efficiently. But there is no breakthrough here. Most of the modern operating systems are extensively utilize memory for disk caching. And for example, page cache or disk cache in Linux is a mechanism that accelerates access to files on non-volatile storage. Linux stores data in free areas of memory and use it as a cache, and all disk reads and writes move through this channel. Page cache approach in Linux is called write-back cache. If data is written, it's first written to the page cache and labeled as dirty. Dirty means that this data is saved in the page cache but also needs to be persisted in the underlying storage device. Dirty pages are periodically transferred to the storage, so non-dirty pages have identical copies in the underlying storage and dirty pages are not. File blocks are written to page caches not just during writing but also when reading files. For example, if you try to read file once, doing one read after another, the second read should be much more faster since it's reading directly from the page cache and no disk I/O is involved. Apache Kafka benefits from the page cache because it may be considered as a free-to-use in-memory cache implementation provided by an operational system that effortlessly lets you use advantages of caching at zero cost. But it would be incorrect to say that Kafka doesn't rely on file system at all. This situation at the moment may seem confusing since we cannot truly define when Kafka stores data to disks. If you remember the producer X setting, then you're probably familiar with acknowledgement policies in Kafka. A broker will return an ACK to a producer after the needed number of replicas save this change. But since we are already familiar with the page cache, does that mean that the change will be written in memory and may be at risk of loss? These assumptions are at least partially fair. So if all replicas fail at the same time, then even when using X-all you may still lose the update because page caches won't have time to persist changes to the underlying storage. So Kafka cluster may tolerate n-1 nodes fail. That means that at least one replica from the in-sync replicas list must remain alive. This scenario when all replicas go down at the same moment and have no time to do their I/O seems to happen very unlikely. It's time to make conclusions. Kafka relies heavily on persistence provided by operational systems. And most of them are able to use so-called page caches acting as a write-back caches. This optimization gives Kafka a handy and fast in-memory caching for free. When an update gets written to a Kafka node, in most cases it means that the change is written to the page cache but maybe not yet written to the underlying storage. It makes Kafka even faster since no synchronous I/O is used on writes, but on the other hand slightly affects fault tolerance. Hope you have enjoyed this video. Don't forget to like, share and subscribe. Have a nice day. Bye.